Okay, so key things to remember. They gave f of x already, so that means you don't have to write anywhere on the paper f of x equals, because they have already done that. So right here, so you don't have to rewrite that. However, a lot of people want to write L equals 18 minus 3x. That's not really standard math notation, so I wouldn't do it for fear of offending the grader. The last thing I want to do is make the policeman mad, and so he gives me 3 tickets instead of 1. Like, do you understand the analogy? Yeah. So I don't want to make the grader angry, so I want to just keep the grader happy, and so they don't really, I don't know, look maybe as hard as they might look. So just write on your paper g of x equals 18 minus 3x. Okay, always put into y1 on your calculator the f, and always into y2 the g. A reminder from last time, you're not allowed to do this. You're not allowed to use the calculator's notation. Simply a rule of the AP test, that's not allowed. So do not do that. Don't do that. Okay. We're just practicing pink, so if you want to do it, either it's just totally up to you. We're just kind of working and then just questions.
Look at you guys go! I'm going to sit for a little bit.
You're good. Jonah.
Just for like notation, because sometimes I put f of x, or in this case, let's say g of x equals 18 minus 3x, and then I put another equal sign, and I put y2, just so that I know that it's y2.
I don't think they'll have any problem with that.
Okay.
I do think with time, you'll get accustomed to, yeah, they're not going to have trouble with that one. No, that's a good question, Jonah. Doing that's okay, because you're just reminding yourself that that's where you put it. Just don't use the y2 symbol anywhere else.
Okay.
That's a good question. Okay, so that's a couple of things to watch out for. Next thing that I see people getting stuck on is this. There are multiple ways to solve this problem. And if you want to use a different method, there's nothing wrong with that. My favorite method is to simply look at the space for which I am trying to find the area. So I'm trying to find the area of S. I'm going to fill S with vertical rectangles. So I just start drawing them. And I always pay attention to, where the top of each rectangle is touching compared to where the bottom of each rectangle is touching. I just draw vertical rectangles as best I can like that. But then I, of course, notice a problem. So easy extra credit on the last day before the break. What problem do I encounter? Hands up, I'll pay everybody. So I'm drawing vertical lines. I'm paying attention to where the top of each line touches compared to where the bottom of each line touches. This line here, we'll change it to blue. I notice something has changed between the blue and all the reds. What's different? Hey, everybody, come on, hands. Need everybody to see it. I look at the top of the rectangle compared to the bottom. What is different? Mostly everybody. Tim?
You're not reaching the x-axis, so you have to do a new arrow.
Well said. No, well said. So, in the red space, the top of every rectangle hits G. The bottom of every rectangle hits F. Okay, how many knew that? 2.3 for Timmy. Katie. We're going to do a little detail here. Just want to make sure it's really clear to everyone. Please raise your hand. What is that representing, really? What is the symbol G of X truly representing? Hand. Like when you see that symbol, you shouldn't see G of X. You should see something else. Reagan.
The y value of, like on that line, I don't know, whatever you're plugging for x.
You're good. So Reagan's saying this symbol really represents an infinite number of different values. They're just different y coordinates along this line. So that symbol represents this y coordinate. It also represents this y coordinate, this y coordinate, this one, etc. 3 points for rating. Hands. How can that one symbol represent a million different numbers? Hands up. How can the one symbol g of x represent a million different numbers? An infinite number of different numbers, really. I just get tired of saying infinite. Jacob.
Because there's an infinite number of x coordinates that you can put into the equation.
You really can't say that better. We've got this formula g of x. You can plug in an infinite number of different x values. Therefore, you can get an infinite number of different y values. So it's representing all of them. Perfect. So f is similar. So all we're doing is saying, okay, got it. We take the y at the top, we subtract the y at the bottom for each and every x. And when we do that, we get the length of a single line. So g of x minus f of x for some x, for like one x, gives me the length of one line. If I multiply by dx, I get the area of one thin rectangle. And you need to talk more about it. Awesome. We don't want the area of one rectangle, we want the area of many rectangles. So we've got to do what Jacob said, 2 more for Jacob. We've got to plug different x's into this formula. So, entire room again. What x's do I need to be plugging into that formula? Hands up. What x's do I need to be plugging in so I can be finding rectangular area, followed by another rectangular area, followed by another rectangular area, followed by another. If you don't know the exact number x to plug in, at least raise your hand and describe, oh, we need that x, and just point to it or something. For a few more hands. Janessa.
Where L and F intersect.
So Janessa looks right up here, and she says that's the spot where the space begins. That's where I'm going to draw my first vertical rectangle. Therefore, that's the x I must first plug into here. That's the first x I'm going to plug in, is x equal 3. Okay. Find a way to talk to me if that's not clicking. Wave at me, shout violently. Don't throw anything, please. Question. Cool. So I plug in that x. Now here's what the calculator is going to do. It's going to plug in x equal 3. Then it will plug in x equal 3 point, basically 0, 0, 0, 0. I can't remember exactly. We'll go with this for now. Come on board. 1. Then it will plug in x equal 3.000002, etc. So the calculator is producing area after area after area after area, one at a time with different x's. Hands up. What's the last x that I plug in? Everybody, come on. What's the last x that I want the calculator to compute? Hoping for a few more hands. There we go. Let's go to Jonah.
Wait, are we talking about? Oh, 4.
You okay? So are you okay? Like what's this computing, Jonah, right here?
The y values on the dfx graph.
Perfect. This one is computing.
Y values on the fx graph.
Nice. When I take y at the top, subtract y at the bottom, what am I computing?
The rectangle. The distance between.
There we go. Distance. So I'm getting length of that line.
Yes.
Then I multiply by, so this gives me the length of the rectangle. This is the width. When they're multiplied together, I get the area of the rectangle. I'm going to do that for this big long list of x coordinates. So each time I plug in a different x, calculator calculates a different rectangular area. Good there? Cool. Therefore, I want to do area after area after area after area. What's the last x I want to use?
4.
4, which you can find on your calculator. This turns out to be x equal 4. Please raise your hand if you understood that that was the last x that should be plugged into this formula. Show me your hand. 2 points. Okay. 3 for John. Question. Please. Okay.
Still a little confused how we got the 3 and the 4.
Good question. Are you okay with the idea that this formula will be computing the area of one narrow rectangle?
Yeah.
Awesome. So all they did is they took their calculator, graphed this, and said, I've got to find where these two touch. So they did an intersection of the G formula and the F formula. Did I answer that?
Yeah.
And then they went and found the 0 of the F. Is that your question?
Yeah.
2 points. 1 element. Okay. Now what I notice is if I keep filling the space with rectangles, so please raise your hand, entire room. What is common about every one of these green rectangles? What's the same, like what do they share? What trait is common to every single green rectangle? Hands up. What trait is common to all of them? Let's go, Ella.
They all have the same bottom line.
What's the bottom y coordinate for each green?
0.
Good. And what's the top y coordinate for each green?
Is it
G of x. G of x. Because, again, each green rectangle is at a different x coordinate, so I can use that G of x formula to find the y coordinate at the top of each green. So what I want to do then is I simply want to take G of x multiplied by D of x. Okay. You had your hand raised a moment ago, 2 points, 3 for Ella. Please raise your hand again. Tell me what is going to be calculated using this formula. What is that formula going to calculate? Hands up. What's that going to calculate? G of x multiplied by dx. What will that calculate? Hoping for a few more hands. Let's go, Sophia.
So just the area of like one of the rectangles.
Perfect. This will calculate the area of a single green rectangle. Sophia, how do we indicate which rectangle we're talking about?
You put in different x's.
Perfect. We put in different x's. So the x is how we specify which rectangle. The formula then calculates the area of a rectangle. Sophia, which x do we want to start with?
X equals 4.
Good. And which x do we want to stop with?
Whatever x is.
Look in here. Yeah. So you'd use your calculator again to find that x. Turns out to be 6. That will calculate the area of all the green rectangles. As if you knew that before Sophia explained it. 2 points. Okay. Questions? So I've got to add those two together. So it's this plus this. Then I run it through my calculator. Has anyone done it already? What do you get, Zach?
7.917.
Okay. Let's go. It's crucial again that you don't lose track of how this test is scored, because there's no mercy. Like one of the points, helps if I'd write a 4 here. One of the points is going to be for, if I remember correctly, the limits. So that means it's got to say 3, 4, 4, 6. If there's any error there at all, they don't give you the point. They don't give you half points. It's like 1 or nothing. Integrand is likely the second point. That means this integral must have all of this, including the dx. You've got to have the g of x written on your paper. F of x was already written, so you're good there. You've got to have this integrand. You have both of those, you get the second point. And then the third point is for having the numeric answer correct to 3 decimals. If it's not correct to 3 decimals, you lose that point. Questions about anything? Please, Jacob.
What if instead of writing down like g of x equals what L is, what if you just put like L and just remember that L the entire time? Put L in all the equations and stuff, would you still be fine point-wise?
Gotcha. I'd like Mr. Rechte's opinion on this. My feeling is that L is more of a name of the line, and mathematicians aren't going to like you using it in a mathematical formula. And so I don't really want to ever recommend that.
Okay.
I want to just use g of x because it's standard. Is that okay?
I don't know how they would grade it, but
I don't-
I would just go
Yeah.
with the g of x, f of x.
No, that's my thought. 2 points for Jacob. I made a dumb joke at the beginning. I said it's like when a policeman pulls you over, don't argue with the policeman. Just accept whatever he's going to give you and drive away quietly. Because if you just argue, it's just going to get worse. And to me, the grader's the same thing. I want to do everything I can to keep the grader at peace. So I don't want to use non-standard symbols, just, I don't know. So. Questions? Cool. We'll stop this one and go back to work.